Excuse me. Okay, we are in the second section of Module 1, and today we're talking about function notation. And function notation is when you can tell something's in a function when you see something like this. And what this means, how you say it, is f of x. It's literally how you say this thing. And what a function is, well, I want you to kind of figure out what a function is. I don't want to just tell you because that wouldn't be fun. So you'll see function, like last year in algebra or 2 years ago in algebra, you guys learned how to graph lines like y equals x plus 3. Now we're just changing the format a little bit, so now it looks like f of x equals x plus 3. And there's a reason why we do that. There's a reason why we have functions. Honors will do this in just a second. CP, you don't have to worry about Dix-Roy. Okay, so if you've noticed, I've split my notes into 4 parts. I want to tell you some characteristics of functions. I want to show you some examples of functions, what they look like graphically, and in other formats, and then I'm going to show you some non-examples, and then hopefully by the end we can come up with a pretty clear definition. Okay, so functions, some examples and some non-examples. So here are some examples. Let's say I have a graph. I'm going to show you some graphs. Ugh, rude, why didn't it change? Okay, this circle or oval, if you will, that is not a function. Something else that's not a function, things like this, is not a function. If you didn't want to look at graphs, something else that's not a function, let me show you an input-output table or an XY T-chart. Let's say I have some X's and some Y's, or I might be using inputs and outputs. And let's say I tell you that when X equals 1, Y can equal 0 and 3. So there's 2 occurrences for X. When X equals 2, that Y equals 4. And when X equals 3, I'm just coming up with random numbers here, Y equals 5. So there's a 1-to-1 and there's a 1-to-1. But this one, there's 2 Y values for 1X. This is not an example. So I've got some graphical examples, and I've got some T-charts, some input-output charts that are non-examples. Let's see if I can give you something else. Oh, okay, here's another way, another T-chart. So again, I have my X's and my Y's, or my inputs, outputs. X's are ins, Y's are outputs. And let's say I tell you that there's a -3, and when X is -3, Y is 4, and when X is -3, Y is also 5, and when X is 4, Y is 6. Again, I'm just pulling random numbers, but I want you to take notice of these 2 things that happen. Okay, so some examples. What are functions? What do they look like? Functions can look like a lot of things. They can look like quadratics. They can look like diagonal lines or horizontal lines. Here's another non-example. A vertical line is not an example. Is a non-example, excuse me. So anytime you have a vertical line, here's your X and Y. That's not a function. You can have absolute values are functions, so things that look like this. You can have even something really bizarre. Let me give you a really good bizarre one. Okay, a really good bizarre one is something like this. There's my X, Y. Boom. That is a function. Okay, and some characteristics of functions is that they are, how I always remember them is they're a real world occurrence. So, for example, I can't remember how to spell occurrence, apologies. Sorry. For example, I like to think of a hot air balloon. This, I remember my Algebra 2 teacher explaining this to me. So, if I was thinking about a quadratic, right? I said a quadratic was an example of a function. So when we're on a hot air balloon, time is always our independent. It's our x-axis. And how high I am depends on the time that passes, amongst other things. So if I start on the hot air balloon, I'm at height 0, and then I go up on the hot air balloon, and then at some certain time, I go back down, and then I come back to the ground, thank goodness. Okay, so maybe it'll take this path, maybe it'll take a different path. But what I remember is that at each point in time, like let's say after 30 minutes or however, I'm only in one spot. So So I can only be at one height. It's impossible for me to be in two places at once. So that's why I really like the hot air balloon. It's a characteristic of a function. Another characteristic is that it must pass the vertical line test. So if you draw a vertical line through at any point of the function, it only passes one time. So it only passes here, it only passes here, it only passes here. If it passes more than once, then it is not a function. So for example, a non-function was something that looked like this. And again, if you look at the vertical line test, it hits it twice, so it's not a function. You can't be in two places at once. Another thing I really like, and I want you to write this big under the characteristics, so I'm going to erase some of this. I want you to remember that a function is kind of like a machine. But I've been using these words like input, output, right? So we're going to have our input, which is like our x value. So we have our input, which is like our x. And then we're going to put it into this function. We're going to do something to the x. And then out comes one answer. Our output is our answer, and you can consider it as our y. So for honors, you're going to want to remember Dix-Roy. Dix-Roy stands for the domain. These are all new words for you. The domain is, the domain is all the inputs, which is x, which are all the x values of a function, and range is all of the outputs, which is just the same thing as saying the y values. And we're going to talk about this more this unit. It's just some vocab to throw at you. So how you can remember the D for domain, I for input, and X for X values. And the ROI, you can remember R for range, O for outputs, and Y for Y values. Okay, so what is a function? A function is a set of X and Y values, right? It's a relation. It's a graph where there's only, where each input, I'll say this rather, where each input has only one output. So for each x, there's only one y. So you put something in, you do something to it, you have an x, you do something to it, and then you output it. What we're going to do today is we're going to practice taking expressions, like something like this, for example, x plus 3. And we're going to practice just evaluating a function. So if I say, for example, find f of 1, well, x is 1. I'm telling you x is 1, and all you're going to do is input it into the expression, to the function, and then you're going to get that your output is 4. So if you were going to graph it, you'd know that x is 1, your input, your x is 1, and your output, your y, is 4. And you would just plot that onto a graph, and that's what we're practicing today.